Good morning, students. This is the complete lecture series on water, and this is lecture 1 in this series. I'm Dr. Shikha Agarwal from the Department of Chemistry, Engineering College, Ajmer. The contents of this lecture are distribution of water on earth, sources of water, common impurities of water and their effects, water quality standards, the physical, chemical and biological characteristics of water, the Indian standards of drinking water, hardness of water, definition, types of hardness and disadvantages of hard water. Now, as far as the distribution of water is concerned, all of us know that 75% of the earth is water, and out of this 75%, 97% water is present in oceans and seas, which is salty in nature and is of no use for us. Out of the remaining 3% water, 2% is interlocked in polar ice caps, and once again it is not available to us. Just 1% water is available in rivers, lakes and groundwater, and out of this 1% also less than 1%, generally 0.01% water is available for our use. Meaning to say, as we say, there is plenty of water all around, but the amount of water which is available for human use is less than 1%. Now we come to the different sources of water. The sources of water are surface sources, underground sources, and rainwater. So rainwater is considered to be the purest form of water. The surface sources of water includes lakes, ponds, reservoirs, rivers and seas, and underground water includes springs, wells and tube wells. Now all the sources of water, whether it is rainwater, underground water and surface water, contains some kind of impurities or the other. Rainwater is considered to be the purest form of water. Surface water contains more of free floating and suspended impurities, whereas underground water contains more of dissolved impurities. In other words, whatever the sources of water, they have some kind of impurities or the other. So the common impurities which are present in water, since water is a very good solvent, it will dissolve a large number of substances in it. So the common impurities in water, they have been classified depending upon particle size into dissolved impurities, colloidal impurities and suspended impurities. Dissolved impurities are dissolved salts like carbonates, bicarbonates, nitrates, sulfates, chlorides of calcium, magnesium, potassium, iron, manganese, etc. Even the dissolved gases like oxygen, carbon dioxide, sulfur dioxide fall in the category of dissolved impurities. Colloidal impurities are those whose particle size varies from 1 nanometer to 100 nanometer. So they contain finely divided silica, clay, aluminium hydroxide, ferric hydroxide, organic waste products, coloring matter, etc. Suspended impurities are those whose particle size is greater than 100 nanometer and they can be removed by filtration or settling. They can be organic, inorganic, or they can also be in the form of microorganisms. Organic impurities, they include vegetable and animal matter, wood pieces, oil globules, leaves. Inorganic impurities are like silica, clay, etc. Microorganisms are algae, protozoa, bacteria, etc. Now all these impurities in water, they impart turbidity and color to water, and microorganisms are responsible for different kinds of diseases. Now this is the tabular form in which the impurities of water and their effects have been tabulated. So you can see the different whatever we have studied in the earlier slides, that is written here in tabular form. So impurities like bacteria, algae, protozoa, they cause diseases, they change the color, odor of water, they make the water turbid. Then salts like calcium, magnesium make the water hard. Carbonate provides alkalinity to water. Fluoride causes dental problems. Then there are certain salts which are poisonous also, like manganese and lead, they are poisonous. Arsenic is poisonous, cadmium is poisonous, cyanide affects nervous system, boron is toxic. So these are the different impurities in water. You can just have a look at this slide. Now there are different water quality standards which fall in three categories. One is the physical characteristics of water, then chemical characteristics of water, and the biological characteristics of water. The physical characteristics of water include color, taste and odor, temperature, and electrical conductivity. Now, as far as color is concerned, clean water should be colorless. If color is present in water, it means different types of minerals, salts, pollutants are present in water. Now, odor, once again, water should be odorless and it should have a fairly good taste. So, minimum odor that can be detected in water, it is called the threshold odor number. Temperature is also a physical characteristic. So, high temperature indicates thermal pollution in water. If the temperature is high, then the dissolved oxygen in water reduces, which affects the aquatic ecosystem of water. Now, electrical conductivity of water gives an idea about the dissolved salts in water. So, greater the electrical conductivity means greater the amount of dissolved salts in water. Now we come to the chemical characteristics of water. This is pH. So the pH of normal drinking water varies from 6.5 to 8.5. Then second is hardness, which is due to the salts of calcium and magnesium in terms of equivalents of CaCO3. So this we are going to study in detail in this chapter. The maximum acceptable limit is 500 ppm. The total dissolved solids means all the solids that are dissolved in water, they should not be more than 500 ppm. It can be both organic and inorganic impurities. And how you measure it, you take the water sample, evaporate it to dryness, and you weigh the residue. So that will give you the total dissolved solids in water. Total solids includes dissolved solids as well as suspended solids in water. The other characteristics include dissolved oxygen in water. So, oxygen normally remains dissolved in water and its normal value is 5 to 8 ppm. If the amount of oxygen in water is less, that means the water is polluted. Chlorides, once again, chlorides should be less than 250 ppm. Higher percentage of chlorides causes corrosion of pipes. Fluorides, water should have not more than 1.5 ppm of fluorides because excess of fluorides causes discoloration of teeth, bone fluorosis, skeletal abnormalities, and so on. Sulfates should not be more than 250 ppm. Excess causes scale formation and boiler corrosion. Nitrates should not exceed 45 ppm. Excess causes methemoglobemia or blue baby syndrome in infants. Then biological characteristics of water. Water should be free from all kind of bacteria, virus, protozoa, etc. and algae. The coliform count in any sample of water in 100 milliliters should be 0. Bacteriological standards in water, E. coli count in 100 milliliter of any water sample should be 0. Coliform organism should not be more than 10 per 100 milliliter of any sample. Now, virological standards, if water contains 0.5 ppm of free residual chlorine, then all the virus gets inactivated even in water which was initially polluted. So, it is important that water should contain 0.5 ppm of free residual chlorine. Now, this is the tabular form in which the Indian standards of drinking water have been given. This has been laid down by the Bureau of Indian Standards. So, you need to learn it because you can be asked question on give the different Indian standards for drinking water laid down by BIS. So, this is a question that appears in the exam sometimes. So, need not be explained. So, the acceptable limit is shown in the second column, and if the limit exceeds what is given in the last column, then the water sample is to be rejected. So you can just have a look. I am not speaking out this because you can just go through it. So these are also the standards which are continued. Now we come to something very important, which is the heart of this chapter, that is hardness of water. So here we will define what is hardness of water, then we will discuss what are the causes of hardness. That is all that we are going to do in this lecture. Later on, how hardness can be removed and numericals related to hardness will be discussed in the other lectures. So what is hardness of water? Water which does not give foam or lather with soap is hard water. So this is important. जो पानी साबुन के साथ झाग नहीं बनाता है वो hard water है. Now, what causes hardness? It is due to the presence of soluble salts of calcium and magnesium in water. So, why water becomes hard? You can see the chemical reactions. Actually, soap is nothing but sodium stearate, C17H35COONA. So, when it reacts with calcium and magnesium salts, it will form calcium stearate and magnesium stearate, which is insoluble, and it will precipitate out as white scum. So, you must have seen that at times when water is hard, then when you apply soap, instead of giving lather, it forms a white precipitate. So that white precipitate is due to calcium and magnesium stearate, and it is insoluble in water. Now, how many types of hardness is there? There are two types of hardness. One is temporary hardness and second is permanent hardness. So temporary hardness is hardness which can be removed by boiling. It is caused due to bicarbonates and carbonates of calcium and magnesium. So you can see the reactions. When you boil calcium bicarbonate, it will form calcium carbonate which precipitates out. If you boil magnesium bicarbonate, it will form magnesium hydroxide which once again precipitates out. So you can just filter them. Calcium carbonate, magnesium hydroxide will be removed and the water becomes soft. So since this hardness can be easily removed by boiling, that is why we call it temporary hardness. Permanent hardness is due to the presence of dissolved chlorides, sulfates and nitrates of calcium, magnesium, iron and other heavy metals. It cannot be removed by boiling. So you need special chemical techniques like lime soda process, zeolite process and ion exchange process to remove permanent hardness of water. Now in this table I have compared temporary hardness and permanent hardness. So you get a question on discuss different types of hardness in water and compare them. So temporary hardness is also called carbonate hardness or alkaline hardness because it is caused by carbonates and bicarbonates which are alkaline in nature. Permanent hardness is called non-carbonate hardness or non-alkaline hardness. Temporary hardness is due to bicarbonates and carbonates of calcium and magnesium. Permanent hardness is due to chlorides, sulfates and nitrates of calcium and magnesium. Temporary hardness can be removed by boiling. As we have already discussed the equations, I am not repeating it, but when you are asked to compare, then you have to write the equations in the table. Permanent hardness cannot be removed by boiling, so it requires some specific techniques. Now, hard water is not good for us. It is harmful for us, both at domestic use as well as industrial use. So, if you are using hard water at home, you will see that it is not good in taste when you drink it. It is salty. It does not clean properly because it does not form lather. It is not good for cooking because it contains lot of salts, so it elevates the boiling point of water. So, food takes a greater time to cook. Besides this, in industries also there are a lot of disadvantages of hard water because hard water contains salts. That is why in paper industry, sugar industry, textile industry, it leads to unwanted chemical reactions, and like what we want is different from what we get because some extra salts are present in water. So this is all in this lecture, and thank you all very much. And after this, in the next lecture, what we are going to do is we are going to study how you measure hardness, because hardness is not expressed in terms of calcium chloride, magnesium chloride. There are some other parameters in which hardness is expressed. So we will do how hardness is expressed, Then how you calculate temporary and permanent hardness, what are the different units of hardness, what is the relation between them, all that we are going to do in the next lecture. So that is all for lecture 1. Thank you all.